Hello students, today we will start sound chapter. Now what is the meaning of sound? We have already studied in lower standard. Sound is a form of energy which creates the sensation of hearing in our ears. So these are the keywords. Sound is a form of energy which creates sensation of hearing in our ears. Sound is produced due to vibrations. What is the meaning of vibration? Vibration means a rapid to and fro motion. Now, there is a difference between oscillation and vibration. Oscillation is also to and fro motion. Vibration is also to and fro motion. But oscillation is slower than vibration. Vibration is faster than oscillation. So vibration, we can say it is nothing but rapid to and fro motion of a particle. So I would write here to and fro motion. Clear? Okay. Now, how can we produce vibration? Let us take example of musical instruments. Now we have three types of musical instruments. One is string, like guitar, sitar, violin. These are stringed instruments. Next is wind instrument, like trumpet, flute, bassuri. These are, or mouth organ. These are wind instrument. Then we have percussion. Percussion means what? The instruments which have membrane on it, like tabla, dholak, drums. So we have three types of instruments. So in all three types of instruments, what are we doing? We are producing vibration, either by plucking the strings, that is in guitar, or tapping, like in drums. Drums we are tapping with the help of a sticks. Tabla with the help of your hands or fingers, right? Or mouth organ, the air columns inside the mouth organ will start vibrating. Okay, so what is important for vibrations? Particles are important. Particles which are present inside a medium. So what did we prove here? That vibrations of particles are important. Particles are there only if there is a medium. Medium, for example, medium is air. Then only the particles can vibrate. Which means sound cannot travel in vacuum. If there is vacuum, sound will never travel. For example, moon. Let us assume that I am taking lecture on moon. If I am taking lecture on moon, can you hear me? Answer is no. Why? Because on moon there is no atmosphere. No atmosphere means no medium, hence no particles. Sound cannot travel because there is no medium in it. Clear? So now we will prove that sound needs a medium. We will prove that. So this might prove that sound needs a medium. Let us say we have a bell jar. This is called as bell jar. Okay. Here, this is a cork. This is key. This is a battery. Okay. Here I have a hammer and a gong. And here I have a vacuum pump. Please see the spelling of vacuum. It is V-A-C-U-U-M. This is a gong and this is a hammer. This is a cork or a stopper. So we are proving that sound cannot travel through vacuum. The name of this experiment is bell jar experiment. It is called as bell jar experiment. Now I am pressing this key. The current will start flowing. The hammer will hit the gong. So the key is pressed, hammer is hitting the gong. Hammer is hitting the gong. I can hear the sound. Same time, I am switching on this vacuum pump. Means it will create vacuum inside. So what is happening? The hammer is hitting the gong. The sound is getting is reducing. It is feeble. And after some time, the sound will go away. Means even the hammer is hitting the gong, but you won't be able to hear any sound. Reason is this vacuum pump has sucked in all the air and there is vacuum inside the bell jar. So this proves that sound cannot travel through vacuum. So you can pause the video and copy this diagram. This might come for 2 marks, that explain with the help of bell jar experiment that sound cannot travel through vacuum. Okay. So sound waves are also called as light waves are electromagnetic, and sound waves require material. Hence they are called as mechanical waves. Why sound waves are called as mechanical waves? Because sound needs a medium. Let's perform experiment of tuning fork. So this is a tuning fork. This is the stem. Okay, this is the stem, and this are called as prongs. Prongs. Right now, it is not functioning, so the particles are relaxed. So there are particles which are relaxed. Now I am hitting this such that it starts vibrating. So let us assume that it is vibrating outwards, and then it will vibrate inwards, and this will go on. Means outward, inward, outward, inward, it will go on. Okay. When it goes outwards, so the particles will get a push, so all the particles will come closer. Then when it goes inside, particles again will get back to its original position, that is, they will be relaxed. Now this is happening again and again and again. So what will happen? Particles came closer, then they went away, they came closer, then they went away, then they came closer. Right? This is called as, when particles come closer, this is called as C. C stands for compression. And when particles go away, it is called as rarefaction. Compression means particles are getting close to each other. Rarefaction means particles are going away from each other. And this is like compression, rarefaction, compression, rarefaction, compression. Means you can see that the particles are coming closer, then going away, closer, away, closer, away. So if I make sound wave, it will look something like this. So this shows compression, rarefaction, compression, rarefaction, and compression. So sound waves travel in the form of compression and rarefaction. Okay, so you can just copy this. Now, what is the meaning of oscillation? We will study few important terms related to sound. Oscillation. Oscillation means to and fro motion of a particle. What is time period? Time period, which is denoted by T, the SI unit is seconds. Time period, we have already studied, time period is the time taken to complete one oscillation. Time period means it is nothing but time taken to complete one oscillation. Then we have frequency, denoted by F, and its SI unit is Hertz. What is frequency? Frequency means number of oscillation per second. Number of oscillation per second. What is the relationship between frequency and time period? If frequency is more, time period is less, and vice versa. So they are inversely proportional. So we got the first formula, F is equal to 1 by T. If frequency is more, time period is less, and if time period is less, frequency is more. Then we have something called as wavelength. This is something new for you. Wavelength means, in other words, it is the length of the wave. However, you cannot write this definition. So this is compression, compression, this is rarefaction, and this is also rarefaction. So what is wavelength? Wavelength, it is the distance between consecutive compression and consecutive rarefaction. Like this is compression from here till here. Rarefaction is starting from here, the other one is starting from here. So this distance is called wavelength. Both will be same. It is denoted by lambda. This is read as lambda. It's a Greek letter. So you will write this way. 1 slash, small slash, slash, small slash. The SI unit of wavelength is meter. So we studied oscillation, time period, frequency, wavelength. Okay. Please remember this formula. We are going to use this formula in one derivation. So we studied 4 points. Now we will study the 5th point. I will just write the formula here. F is equal to 1 by T. 5th one is nothing but wave velocity. Wave velocity, which is denoted by letter V. Velocity is nothing but the distance traveled by wave in 1 unit time or in 1 second. So wave velocity, or I can say speed, you have studied that speed is equal to distance upon time. Distance upon time. Now what did we study related to distance just now? We studied something called as wavelength. And time is nothing but time period. We are deriving one formula. This might come for 2 marks. Wavelength is denoted by lambda. Time period is denoted by T. Now can I do this? Can I do this way? Lambda into 1 by T. I am just removing this T and writing it separately. But see here. What is 1 by T? It is F. So I can write V is equal to lambda F. So what did we derive? We derived that wave velocity, or you can say speed, is equal to wavelength into frequency. So this formula we are going to use while we solve the sums. Okay, so please you can just write this derivation. So there might be question based on this. Let us solve a couple of questions. A heartbeat of a man is 75 times a minute. Find time period and frequency. So what is the question? A heart of a man beats for 75 beats. So it makes 75 beats in a minute, in 1 minute. You need to find frequency and time period. That is the question. So 75 beats means I can say 75 vibrations. 1 minute. 1 minute is 60 seconds. What is frequency? Frequency means number of oscillations per second. So we will use unitary method. 60 seconds, 75 vibrations. So 1 second, I can take it as F or X. Cross multiply. 60F. 60 into F is 75. F will be 75 by 60. Now both will go in 15 table. 15 5s are, 15 4s are, 5 by 4. You write any answer, you have to write in decimal. So what is 5 by 4? If you divide, you will get 1s are 2, 5. Is this my final answer? No, it is incomplete. You have to write the unit. So frequency is 1.25 Hertz. Now you need to find time period. What did we study? F is equal to 1 by T. Bring T here, F here. So T will be equal to 1 by F. Now see what am I doing? Instead of writing 1.25, I will use this 5 by 4. So 5 divided by 4. Next step, this 4 will come in the numerator. So it will become 4 by 5. Now what is 4 by 5? If you divide 4 upon 5, You will get 0.8 second. This is the answer. 0.8 second. And here the final answer, time period is this, frequency is 1.25 hertz. You have to write final answer. Make sure, please make sure that you have written the units properly, because units carry mark. Many students get confused that what is the definition of time period and frequency. See, whenever you define time period, the definition starts with time itself. So I will say time taken to complete one oscillation. And what is frequency then? Frequency is number of oscillations. When we say that guy remains absent, or he is frequently not coming to school. Frequently means what? Again and again, means number. So number of time it vibrates, it is frequency. Time period, the time taken to complete one oscillation. Okay, so you can just copy this